Hello.
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 I guess it'd be best to start going around like who we are, what we work on, and why we're here today talking about Solana.
Hi, I'm Uma. I'm one of the co-founders of Succinct. Our company's mission is to prove the world software. So we're building a zkVM, short for zk virtual machine, that makes it easy for anyone to just write normal Rust code and use zk. And we're also building a decentralized prover network that makes it very easy for anyone in the world to contribute proving capacity to make zk easy, cheap, and accessible.
Hello, my name is Jem. I'm one of the co-founders of Sovereign, which is a roll-up infrastructure company. Our flagship product is Sovereign SDK. Basically, we know that building application-specific roll-ups can be quite impactful because that can enable a lot of performance and customizability for the type of blockchain applications people build. And our framework, Sovereign SDK, enables people to just focus on their business logic, and using zkVMs like the ones Uma's team is building, we can turn users' Rust business logic into a rollup that can be deployed on any base blockchain, including Solana.
Hi, everyone. I'm Rachin, the founder of Twine, and we are building, we're basically connecting all the major chains using zk-like clients and allowing developers to build applications on top with single chain user experience. And one of the major components of our product is a zk-like client on Solana, which is what we're going to be talking about today, built on top of SP1.
So I guess, Uma, can you tell us how like zkVMs can change the way people build their blockchain applications?
Yeah, so I think maybe the first thing to ask is, why do we need zk on something like Solana? I think, for example, in Ethereum world or in Bitcoin world, it's super clear why zk is important. Like Ethereum's base layer is pretty slow, it's not that performant, and to really scale and get unlimited execution, you need zk proving to basically have the execution done off-chain and then verifiable on-chain with the zk proof. And that's kind of the common L2 roll-up-centric roadmap architecture that people in Ethereum world are familiar with. And I guess people in Solana world are only getting familiar with this over the past few months, maybe, or past year with the concept of network extensions. But I would say broadly, it's kind of a new concept. I think to make the example really visceral, one example that might illustrate why we still need more scalability than even what is available on a performant base layer like Solana is taking the example of something like Hyperliquid, where if you want to build something like that, perps experience on like Hyperliquid on Solana L1 today, that's just simply not possible. And so there's a bunch of teams that are trying to build these like zk Hyperliquid style experiences that are more performant than something you can build even on a base layer like Solana. And for that to make execution of these perps exchanges verifiable so that they can't take your money, you need the verifiability of zk. And Chem, you can talk about one of the teams that's building a Sovereign SDK with SP1, hopefully with this exact use case in mind a bit later, but I think that's a really illustrative example of why we need zk.
One thing I can add on top is like, it's not only about scalability of performance, but also about like having this custom sequencing rules and all that stuff that you can't do now on Solana, which is why you would also want to build something like zk Hyperliquid on top of Solana.
Yeah, I guess to give a bit more to go a bit more into depth about like how these teams are building these, how they're using these zkVMs and how they're building these rollups to build a potential Hyperliquid competitor in Solana. The rollup architecture, I think, or the network extension architecture, from whichever ecosystem you want to talk about it from. One thing that is different from a regular blockchain architecture is that rollup architecture trades off real-time censorship resistance for eventual censorship resistance. But by making this trade-off, the rollup based blockchains can have this like authorized party called sequencer that can give stateful responses after each transaction execution. And if you're providing a service like an exchange, that can be very helpful, because on Solana, even with the best consensus algorithm improvements and like a network like gossip protocol improvements, it's really hard to take the block times like below like 300 milliseconds or so. And when people build exchanges on like such a network, there are times where like market makers are like racing with arbitrageurs to cancel their trades, and as a result, market makers like default mode is losing money or like not making as much as money as they do in places where price discovery occurs. So for not every type of blockchain-based application, but for like these like specific types of blockchain applications, it makes a lot of sense to run on like platforms that have eventual censorship resistance, but as a result, we can have transaction confirmations at the orders of regular web servers. And these are basically rollups. And like we work with teams like Bullet and Nebula that are building basically these verifiable servers using like rollup frameworks that can have blockchain applications that are running these exchanges on their rollups.
Yeah, I think the cool thing about the Sovereign SDK architecture is that or really any real-time rollup sequencer architecture, is you have your transactions going in, and then you get responses in real time. So you're basically getting pre-confirmations for everything. You can code your logic as if it's a normal Web 2 database, or you're building a normal Web 2 application. And then in the back, it all becomes verifiable kind of after the fact. So you're streaming in all these transactions, then later you package them together, you generate a ZK proof of them using a zkVM, and then you can post that proof to an L1 like Solana or an L1 like Ethereum to basically gate the deposit and withdrawal of funds. And what's really nice about that is, well, of course, you have this real-time experience that is like very powerful, but also from a developer perspective, when you write your application, in your front end, for example, you don't have to like wait for a transaction confirmation or, have an annoying pop-up or stuff like that. You can just program as if it's a normal API. And then also because of zkVMs, where you can just use ZK with normal code, you can just write your application or business logic in Rust as you would a normal web server. And then you get kind of verifiability in the back where that Rust is then thrown into a zkVM and then proven so that people know that your server is not doing malicious stuff. It's not, it's not able to take your money. It follows certain properties that we want.
Yeah, and if it's built in such a way, like the interesting thing is that literally when this rollup or like the sequencer is first executing transactions, it's regularly just like executing native Rust code. So it's really not that different from a regular web server. After the fact, in an async setting, you can compile the same code to the zkVMs. zkVM compatible like RISC-V instruction set, and you can then later like do the proving. So with just a single code base, you get both native execution and then verifiable settlement after the fact.
Rachin, do you want to talk a little bit about Twine and what you guys are building with multi-settlement and light clients?
Yep, 100%. So one of the problems that Solana has had over the years is the idea of light clients, where the idea is instead of having to run the full node to verify Solana state, you can just verify this very small succinct zero knowledge proof to make sure that the state that you are accessing is valid. And as a result of that, you can make sure that you can check that some events have happened or not on Solana without trusting any third parties, basically. So yeah, because of the way that Solana is designed, making a lot of the trade-offs of performance, you can't really succinctly check as easily as you can do it in Ethereum, for example, because all of the state is not Merkleized on Solana itself. So, so pre-SIMD to 215, you could still like check if like, you know, your account. So there's this thing called account delta hash on Solana that includes the root of all the accounts that were changed during that slot. But after SIMD 215, it's getting removed. And there's this new thing called account lattice hash, which is something that we're working on now. With that, now, like, you know, with some constraints, you can verify, okay, like, you know, for example, in doing a deposit on a Solana L2, you can check if, like, you know, this deposit has happened or not, or like, you know, in case you want to withdraw your funds back from the L2, you can check if, like, you know, this withdrawal request actually came in on Solana as well. So all of this fits in really well. Yeah, the idea of multi-settlement, the main product that we're basically building is the idea of having multiple. So you know how in L2s today, the idea is like you can have a trust minimized bridge from the base layer itself. So most of this has been on Ethereum land today, but there's no reason why you know, this can't be extended to Solana or Bitcoin or any other major chains, for example. And yeah, for us, the idea is like, if we extend this across multiple chains, you can have an execution environment where you can just deploy your single chain application, but have access to liquidity and users from different chains at once. So that's a big unlock for developer experience as a whole. Yeah, that's basically what we're building.
In that architecture where you like are proving a single application state to multiple different chains, so I guess to have that multiple settlement, how does like zkVMs help in that context?
So you will be running all the application logic in a zkVM. So so if it's an EVM chain, you would be running zk, like a reth on top of SP1 or RISC0 or any zkVM, for example, or if you're running an SVM chain, then you'd be running some SVM implementation on SP1 or any other zkVM. And then once you prove the state transition that happened in a block, and once you have a proof for that block, you post that to all these chains that you settle on, and all of them verifies whether the proof was correct. You know, proving is actually the most expensive part, and verification is only is one of the cheaper part of the system. So so it scales quite well.
Makes sense.
How about Sovereign Labs? What are you building? And you know, one of the things that got me excited about Sovereign Labs was how you guys are thinking about building Internet of Rollups. And this definitely, to me, is one of the like obvious end games that we're headed to in the blockchain architecture. Yeah, would love to learn more about that as well.
Yeah. So when we first started, we really obsessed over the idea that rollups are going to be running on a single blockchain, single dataability layer, and every rollup is going to generate zk proofs, because as the zkVMs bring the cost down like to almost inconsequential levels, we're going to see almost all like applications move on to zk rollups and generate zk proofs for each of their like updates, each of their blocks, and we imagine that there will be parties that go in and aggregate all these proofs from all these different chains, aggregate them into a single proof, and then this single proof would be distributed to every rollup, so that every rollup can be connected by verifying a single zk proof to all the other applications, to all the other rollups that exist in a blockchain like ecosystem. And so that's like the Internet of Rollups idea. At the same time, right now, like as we work more and more with application builders, we're seeing that people put a lot of emphasis on having bridges, having access to liquidity as much as possible, and way less so in whether that like bridge is secured by optimistic proofs, a multi-sig, or zk. And in settings where like the multi-sig is even like with trustable authorities, that might even be preferable given like the novelty of these like technologies. So I think like the end game is pretty clear for almost everyone now. The way we have TLS or HTTPS on almost every internet request, we're going to have zk proofs verifying the state of our applications as we move value between these applications. At the same time, like the requirements of like builders today are different, and we understand that. So I think for us to get to that end stage, we just need to be pushing down the costs of these zk proving networks as much as possible. And I'm sure in a few years, they'll be pretty at a similar place to regular server costs.
Oh yeah, and the one other question I wanted to ask about Sovereign SDK is kind of maybe diving into one of your customers who's actually building on Solana. So Bullet, so like what are they building? How do they leverage the framework? How are they leveraging a zkVM? And what does their application logic like actually do? And why would it be impossible to build on the L1?
So the main, like the most important thing in that question, I guess, is like, why would this not be possible on the L1? The main reason is that in the L1, any user transaction or any market maker request that you do on the application, if market maker is trying to cancel trades or place trades, that's going to take at least 400 milliseconds or so with stake-weighted connections. And if it's a regular user is doing it, it's most likely going to take about like a second or so. And when a market maker is in a position where it doesn't have the latency advantage it normally has compared to regular users on centralized exchanges, then it's in a place where like it's competing with every other liquidity provider to make money. But that means like it's not using its capital efficiently. As a result, exchanges, if they want to incentivize long-term market makers, they have to provide very low latencies to like basically they really need to provide low latency response times to these market makers. The main reason the Bullet team is building with us, like among many reasons, but I'd say like one of the biggest advantages is that we can provide them an execution environment where they can respond in 2 to 5 milliseconds to their market makers, to their users. So the market maker can really like use its latency edge and canceling their transactions as fast as possible. Or like if they see a retail order coming in and they see like juicy trades from retail, like catching them as quickly as possible so that they can be profitable as they run their operation. That's like one of like the main benefits these verifiable servers provide to the builders. Another one is you can have like, as you pointed out, application specific like sequencing properties. Again, in the exchange world, Hyperliquid guys wrote a blog about this, and so a lot of people know it now. To make sure that market makers which are bringing liquidity to these exchange environments, to make sure that these market makers don't get into races with arbitrageurs that might want to snatch their stale orders. And when I say stale order, let's imagine a scenario where price discovery occurs on Binance and market maker had lots of like lots of orders like listed for a certain price, but the price moved on Binance really quickly, and during that time gap where the market maker is unable to cancel those transactions, someone else might come in, like an arbitrageur might come in and really quickly take those. And once they take those, the market maker has just lost money because they also saw the price movement. They just couldn't cancel cancel their orders fast enough. So to not get into these sort of like situations, one interesting sequencing rule, an application specific sequencing rule, is to make sure that every take order is delayed by some certain amount and cancel orders are processed immediately. When you apply that to exchanges, arbitrageurs that are racing to make free money off of like the stale post orders need to basically get pushed behind the cancel orders that a market maker might make. As a result, you like make your application environment a bit more less susceptible to toxic order flow. In that way, you can potentially you potentially need to provide less incentivization to the market makers, and they're just more happier to be on your platform. So that's another benefit that we provide to application builders.
Yeah, that makes sense. So I guess to summarize with ZK, application builders can customize their sequencing, have better rules specific to their application, can have real-time responses, but then also preserve verifiability and then tap into the liquidity of these underlying L1s. And then with what Rachin is building, for example, you can actually tap in potentially to the liquidity of multiple different layers, which is also very nice instead of having to pick one. So yeah, overall that seems very compelling.
Uma, to end things off, you're a big advocate of how everything should be ZK. Can you give us one reason why something should not be ZK?
I think especially on architectures where there's a lot of emphasis on verifiability. So for example, Ethereum's roadmap, or even things like Bitcoin where your L1 is just so scarce, basically. Your L1 resource is so scarce. You have to have ZK because that's your only option. I think for something like Solana, which lies on a different point in the trade-off space where the L1 is a lot more performant, but it's much less verifiable because running a node costs a lot more. It's much more expensive. You require a much bigger box. It's in a different part of the trade-off space. So the set of applications that you might stick on ZK on Ethereum would be very different than the set of applications you would stick on ZK and Solana because the L1 can just do more. So I think basically where you're lying on that trade-off space and what underlying ecosystem you're building on matters as to how much you should use ZK. And so, for example, I think certain applications on Solana today, if you're trying to tap into the liquidity of the underlying L1, you're using a lot of composability with the other applications on the chain, then I think making your own rollup maybe doesn't make the most sense. But I think, for example, for the team Bullet that we've talked about a lot, that's using Sovereign SDK, they literally were building a perps platform on the L1 before, and they were dissatisfied with the experience. They felt like they couldn't have a competitive experience with a centralized exchange or even other offerings like Hyperliquid, which is why they decided to transition and make their V2 with ZK. So that's a very real example in practice of that migration happening. And so it shows if you have a really, really high throughput application that requires all this specialized sequencing and things like that, then ZK makes sense. But if you're, your own application that's a borrow lend protocol that requires composability, then I'm not sure doing it on your own rollup makes a lot of sense.
Yep, got it. So especially for things that requires composability with other applications living in the same state space is where ZK does not make sense?
If you can just put it on the L1 today, then yeah, I don't know that ZK makes the most sense. But for example, on Ethereum, you would need your own rollup to do all this stuff with subsend transactions, and then that rollup kind of has to be ZK.
Yep, that makes sense.
Cool. Well, I think we're just about at time. So yeah, thanks for chatting. Chem and Rachin, and hopefully you guys learned something about ZK.
Thank you so much, guys.
Thank you.